Good day, everybody. Hope you are doing great today. Today, we are going to talk about how to find out the minimum sample size necessary. So, here I go. A farmer wants to maximize the size of the eggs laid by the chickens in his farm. He wants to give his chicken a new type of feed. The standard deviation of the eggs laid by the geese that were given this feed is 7.5 gram. Of the following, which is the fewest number of eggs that should be sampled to obtain an estimate within 0.5 gram of the true mean of egg weights at a confidence of 95%. So the options are A, 29.4, B, 100, C, 609, D is 864. So let me make sure this is D as in David. D is 864. And E, option E is 865. Okay. So we have to use the minimum sample size formula. Solution. Minimum sample size formula is N equal to, N is the sample size, Z alpha by 2 multiplied by sigma divided by margin of error and whole thing squared. So I have to explain what each of these terms are. So if I create some space, so Z alpha by 2 is the critical value of Z. Critical value of Z for 1 minus alpha percent level of confidence. Or I should clear 1 minus alpha times 100%. This is multiplied by 100% level of confidence. So alpha, this is read as alpha. This is level of significance. And that is equal to 1 minus C, where C is the level of confidence. Thus, alpha is equal to 1 minus C. For C equal to 0.95, alpha is 1 minus 0.95% confidence is 0.05. So here I have the standard normal curve. Okay. So at the center, Z is equal to 0. This is the standard normal curve. So please do not quit right away, because I'll give you some important tip at the end of this program. And if I want to make this a little bit colorful, this is your confidence level. This is C is equal to 0.95. This is the area in the center. So area in two tails is equal to alpha. Area in each tail, because of symmetry, symmetry means the left half is equal to the right half, is equal to alpha by 2, is 0.05 divided by 2 is 0.025. So this is 0.025, and this area is also 0.025. These two Z values, this one and this one, this is the critical value of Z. Okay, so if I create some space, Z alpha by 2 is critical value of Z. Okay, plus minus Z alpha by 2, because it's minus on the left of 0 and positive on the right of 0. So area to the left of minus Z alpha by 2 is alpha by 2. Similarly, area to the right of Z alpha by 2 is alpha by 2. Now, moving further up, we know alpha by 2 is 0.025. So go to TI-84 calculator. Okay. Press the second key on the top left, then the verse key on the third row, then scroll down to number 3, which is in norm, inverse of norm. We use this function when the area in the left tail is known, for example. Select or enter, I should say. So second verse, third row, the number 3 is in norm. We enter the following information. Enter. After this, enter. And then area in the left tail is 0.025. Mu is already set as 0 because the center is 0. Sigma is 1 for standard normal curve. Do not change it. Then go down to paste. Put the cursor or the flashing rectangle on paste. Okay, and then hit enter twice. So let me create some space. You will get area is 0.025. Area in the left tail. Do not change mu and sigma. Paste, enter, and enter. The value of Z alpha by 2 minus Z alpha by 2, where or minus Z alpha by 2 is 0.025, is minus 1.96. That what you will get from the in norm function. Okay. So by symmetry, Z alpha by 2 is on the right side is 1.96. Okay. This is what we are going to use in the formula. For sample size, for minimum sample size. Okay, if I move this up, the formula is over here. I will repeat it, I'll write it down. Minimum sample size, sample size. N is equal to Z alpha by 2 times sigma divided by E. Okay, so moving up, sigma is given as 7.5 and E is the margin of error. Margin of error is defined as X bar minus mu, sample mean minus population mean. Okay. So all this information has been provided to us. If we take a look, margin of error is to be maintained at 0.5 because it says of the following, which is the fewest number of eggs that should be sampled to obtain an estimate within 0.5 gram of them. That means margin of error is 0.5 gram. Standard deviation is given as 7.5 grams. So we will, I can do the problem over here now. So N is equal to Z alpha by 2 times sigma divided by margin of error square. Let me erase that and write it nicely. So N is equal to Z alpha by 2 times sigma divided by margin of error square. So N is equal to 1.96 multiplied by standard deviation is 7.5 and margin of error is 0.5 whole thing squared. Okay, so using my TI-84 calculator, I'll put the left parenthesis 1.96 times 7.5 is the standard deviation divided by margin of error of 0.5, right parenthesis, and then do not forget to press the X square button to exponent it to 2, and the answer is not 864.36. So the correct answer is, let me get rid of all this. N is 865 is the answer. Okay, so this is the answer, not 864.36. So correct answer, correct option, answer is E. Okay. Remember 864.36 is rounded up. We do not round it down. Hence D is not the correct answer. E of 865 is the correct answer. So let me get rid of that. Oops. And this is Okay. So let me explain to you. Let me give you the tip I wanted to give you. Okay. The formula to use is this. Minimum sample size is in parentheses critical value of z alpha by 2 times sigma divided by E margin of error, the whole thing squared. Z is the critical value for 1 minus alpha times 100% level of confidence. Alpha is the level of significance is equal to 1 minus C, or alpha itself is 1 minus C. For C equal to 0.95, alpha is 1 minus 0.95 is 0.05. What is that alpha? It is the area in two tails. Now, the standard normal curve is symmetric. That is, the left half is equal to the right half. So area in the left tail is equal to area in the right tail, and total together is 0.05. Hence, area in each tail is 0.05 divided by 2 is 0.025. People forget to divide alpha by 2 to find the critical value. Area to the left of the negative critical value minus z alpha by 2 in the left tail is 0.025. Definitely not 0.05, it's half of it. Now we can use TI-84 to find this critical value. Second, verse 3 will take you to IM norm. Area on the left tail is 0.025. Mu is 0, sigma is 1. Pest, enter twice and you will get the critical value as minus 1.96. Because of symmetry, area, Z alpha by 2 critical value on the right tail is positive 1.96. And then we are going to use this formula. Remember, E is the margin of error, which is sample mean minus population mean, which is given as 0.5 in the problem. So we plug everything correctly in the formula and do not forget to square. N is squared, okay? And if you get 864.36 answer, we round it up, not round it down. Why do we round it up? We round it up so that we maintain the margin of error. We do even better in margin of error if we round it up. What does it mean? That means if we round it up to 865, our margin of error will be less than 0.5, which is very desirable. Okay, so the answer is 865. I'll stop here today. If you have any question, comment, write me a note, and please give me a thumbs up. I appreciate that. That makes me work harder. And please write me something. Make a comment. Okay, it makes life interesting. I'll respond to your comment personally. And if you like this video, share with your friends. You and your friends subscribe to my channel, Math Science Topia, by hitting the red subscribe button at the bottom right corner, and let YouTube know that you'd like to be notified every time I upload a new video. So please come back tomorrow to watch a new problem, new solution. Again, thanks for watching. Take care. Have a nice day. See you tomorrow.